Let's look at some examples involving powers of 2. This will give you an opportunity to practice with your powers of 2, but also to see why they're important. So the first question is, how many bits would be needed to store the number 750? Well, first thing that I'm going to observe is that 750 lies in between two powers of 2, which are 512 and 1024. I can also see that 512, this is going to be 2 to the 9th power, and 1024, this is going to be 2 to the 10th power. And so you might be torn as to say whether it would be 9 bits or whether it would be 10 bits. Remember that 2 to the 9th can store, or 9 bits can store up to 512 different numbers. Obviously 750 exceeds that, so it's going to need to have the 10 bits. So 10 bits can store any number up to 1023. Remember that we have to use one number for 0, so there's 1023 of them left over, and certainly 750 would fit within that, but it would not fit within 9 bits. What is the largest number that could be stored with 9 bits? Well, I guess I kind of just answered that a little bit. 2 to the 9th is equal to 512, and remember that a good shortcut for remembering this is that 2 to the 8th is a very important number. This will be 256. And 2 to the 9th is equal to 2 times 2 to the 8th. 2 times 256 would be 512. So remember that there's one value used for 0. So 511 is the largest number. In general, the answer to this question will be 2 to the nth minus 1. Because 2 to the nth is the number of possible combinations, we always use one of them with the number 0, leaving 2 to the nth minus 1. Approximately, what is the value of 2 to the 25th? Now, approximately here is really relying on the fact that 1024 is approximately equal to 1,000. So anytime that you see approximately in one of these questions, it's really saying, okay, you can round 1024 down to 1,000. It's like, that's 1 kilobyte or 1 kilobit. We're going to call that 1,000, but it'll still be really, really close. So 2 to the 10th is approximately equal to 1,000. And 2 to the 5th, we know that 2 to the 5th is exactly equal to 32. Remember that 2 to the 6th is 64. That's an easy one to remember with the 6's. Divide both of those by 2 and you get 32. And so 2 to the 20th will be approximately 1 million, because that's 2 to the 10th times 2 to the 10th. And therefore 2 to the 25th is approximately 2 to the 20th. Well, it is exactly equal to 2 to the 20th times 2 to the 5th, which is approximately 1 million times 5, which would be equal to 5 million. So most of the time after you've had some practice with this, you'll be able to do that sort of calculation in your head. Then the really nice thing is that 2 to the 10th is about 1,000. So it doesn't really matter. Those become very easy to multiply: 1,000, a million, a billion, a trillion, and so forth, which we see in part D. What is the power of 2 that is approximately 4 billion? Well, we know that 2 to the 10th is equal to 1,000. 2 to the 20th is, well, these are approximately equal to 1 million. 2 to the 30th is approximately equal to 1 billion. And we know that 2 to the 2nd power is equal to 4. So therefore, 2 to the 32nd power is going to be equal to 2 to the 2nd power times 2 to the 30th power, which is 4 times a billion. And therefore, we're looking at 32 bits. So this sort of calculation these sorts of calculations are the ones that hopefully you'll become very accustomed to and be able to sort of do them without putting a lot of thought into them. But of course, it only becomes comfortable after you've done it for a number of times. Thanks for your attention.